Everybody. In this video, I'm going to go through some Excel tips for this week's homework, which is the rest of chapter 6. So section 6.2 is super basic. It's just basic probability, and you could use Excel to do it, but honestly, it's probably just easier to use your calculator. So the first example I'm going to do is from section 6.3. So section 6.3 is all about expected value. And the way that you calculate expected value is you list the possible outcomes in usually it's dollar amount, but it could be time. Like this one is actually time. But you list out all of the possible outcomes, and then you find the probability of each of those outcomes. And then you multiply those two results together and add them all up, and that's the expected value. So on question 5 in section 6.3, it says, suppose that you arrive at a bus stop randomly, so all arrival times are equally likely. The bus arrives regularly every 70 minutes without delay. And the question is, what is the expected value of your waiting time? So first of all, we need to list out all of the possible outcomes. So if you show up to the bus stop randomly, and the bus arrives regularly every 70 minutes, it's possible that you might wait 0 minutes, or 1 minute, or 2 minutes, or 3, or 4, or 5. And I'm just going to use Excel's feature that allows you to fill that out. So I don't have to type all the numbers. But these are basically all of the possible minutes that I could end up waiting. Now, I'm going to end this list at 70, and I'm not going to include 70 because the bus arrives every 70 minutes. So waiting 69 minutes would mean that I had just barely missed the bus. But if I waited 70 minutes, the bus would arrive, and that would be it would be arriving, which would be the same outcome as waiting 0 minutes. So these are all of my possible outcomes, and most of the problems on the homework have less outcomes than this. But this is kind of a longer problem, I guess. And the next thing I need to do is I need to calculate the probability of any one of these wait times happening. So since I'm arriving at the bus stop randomly, that means all arrival times are equally likely. And so since there's 70 possible arrival times, and this particular one is one out of those 70, and they're all equally likely, I can calculate the probability as 1 divided by 70, because there's 70 possible outcomes, and the outcome of waiting 0 minutes is one out of those 70 outcomes. So I'm just going to copy and paste that number all the way down. And right there as well. And once you know all of the possible outcomes and their probabilities, then you multiply the outcome by the probability that that outcome happens. And by the way, these outcomes can be negative. Sometimes, like if you're playing a lottery game and you win if you get this number, but you lose if you get that number, these can be negatives. But in this case, you don't wait a negative amount of time at the bus stop. So we're just going to leave it at that. And when I multiply each one of these outcomes by their probability, I get these numbers here. Now, the expected value is basically the sum of all of these numbers. So if you were doing this on a calculator, you would add up all of those numbers once you had found them. And that tells me that the expected value of the waiting time is 34.5 minutes. And that's how you would find the expected value on that. And the way that you would find the expected value for any expected value problem is similar, where you just list out the outcomes, list out their probabilities, multiply each individual outcome by its probability, and then add those results up. And basically what this expected value is telling you is that on average, if you were to show up randomly to the bus stop every day for a large number of days, on average, you would wait about 34.5 minutes. Now, sometimes you would wait more than that, sometimes you would wait less than that, but on average, you would end up waiting 34.5 minutes. And the next question I want to go over is question 6 from section 6.4. So, 6.4 is all about vital statistics like birth rates, death rates, life expectancy, and so on. And one of the things that you'll see showing up in this section a lot is that you're looking at rates per large groups of people. So, for example, in this one, we're looking at the birth rate per 1,000 people. Sometimes it might be per 100,000 people or per 1 billion. And the reason why this is useful is because oftentimes we compare vital statistics from various groups. For example, you might compare the birth rates of multiple different countries. And it's not helpful to just look at how many people were born in a country in a certain year, because some countries are bigger than others, and you would expect a bigger country to have more births. But if you look at the birth rate per 1,000 people, that will give you an idea of which countries are tending to have babies more often uh, with respect to their population size. So, to solve this problem, I'm going to download the let's see if I can copy and paste it. No. Okay, I'll just download this really quick to Excel. Okay, awesome. So, in this table, we are given, goodness, why will this not? There we go. So we're given two different regions and then the country as a whole. Um, And we are asked to find the birth rate per 1,000 people for the entire country. So that means we're going to be looking at this row here. And since we're looking at the birth rate, we want to compare the number of births to the entire population. So the entire country's birth rate is going to be calculated as dividing the number of births by the population. And then that gives me a decimal because that's basically telling me how many births are happening per person. But I want to figure out how many births are happening for every 1,000 people. So I'm going to multiply that result by 1,000. And that tells me that there's 12.57 births happening per 1,000 people. And this is more of a useful number than if I had left off the 1,000 piece because it doesn't really make sense to look at, well, like how many decimals of a birth are happening per person. It's much more reasonable to look at a larger group of people, like 1,000 people. So it said round to one decimal place, so I'll make that 12.6. And that's how you do that question. Now, some of the questions may ask for death rates. Some of them may ask for, um, the birth or death rate of a certain region. But the basic idea is when you're asked to find a rate, you find the rate per person by just dividing the birth by the population or the death by the population. And then you multiply by whatever scale they're asking you to scale it by. So in that last problem, it was for 1,000, like for every 1,000 people. So that's how you would do that question on section 6.4. All right, the next example that I want to go over is question 7 from section 6.5. So we're given a table that shows the outcomes of guilty and not guilty pleas in 1,026 criminal court cases. And we're asked to find the probability that a randomly selected defendant either pled guilty or was sent to prison. So we're given this information here, and I'll just download this to Excel really quick. So I've got that. Maybe. There we go. And I am looking for the probability that the defense. Why is this not moving again? Okay, there we go. Um, so I'm asked to find the probability that the defendant either pled guilty or was sent to prison if you were to randomly select a defendant. So to do this, I'm going to use the OR formula, and this is the reference sheet for test 4. It should say test 4, not test 5 there. So I'm going to use one of these two formulas. Now, these two formulas are actually the same formula because if you have non-overlapping events, the probability of the two events happening together is impossible. It's zero. And so this formula is actually not necessary because you can always use this formula because this will equal zero in the case of non-overlapping events. Because basically, what this formula is saying is if you're looking for the probability of event A or event B happening, you add the probabilities of the two individual events together, and then you subtract the probability of both A and B happening together. And the way that you calculate this out, sometimes you can just get it from the table, which I'll show you how to do. But I'm also going to show you how to use the formula to find this. And that's given up above here. And in this case, the formula that will always work is this one. Because if you're finding the probability of A and then B happening, you take the probability of A and then multiply by the probability of B, assuming that A happened. And if they're independent events, the probability of event B happening, assuming that A happened, is going to be the same thing as event B happening. Like, for example, if you were flipping a coin twice and you wanted to find the probability of getting two heads, so this would be the probability of getting a head and then a head, you would multiply the probability of getting a head, which is 1 out of 2, and then you would multiply by the probability of getting a head, assuming that you got a head the first time. So the probability of getting a second head, assuming you got a head the first time, would still just be 1/2 because the result that you get on your first coin flip doesn't impact your second one. And so in that case, it would be the same thing as the probability of B. But sometimes it's not the same, which will be the case in this one. So to figure this out, I'm going to basically calculate out each part of my formula. So my two events that I'm looking at, whoops, are either the randomly selected defendant pled guilty or was sent to prison. So we're looking for plead guilty is event A. So probability of pled guilty is our first one. And then the probability of sent to prison is our second one. So those are the two individual events, and we're trying to find the probability that either one of those happened. So going back to our formula, to calculate this out, I need to find the probability of event A happening, so probability pled guilty, plus the probability of event B happening, and then I also need to find the probability of pleading guilty, whoops, and being sent to prison. And once I have those results, I'll add these two together and subtract this one to find the probability of one or the other happening. So to calculate this out, I first want to look at what's the probability that they pled guilty. Well, out of all of the possible outcomes, so I'm going to write this total here. In fact, actually, let me just find these row totals because that will be helpful too. So the total number of people sent to prison, if I add up that row, is 455. And if I copy that to the next row, the number of people not sent to prison is 571. And then add these up. The number of people who pled guilty is 953. And the number of people who did not plead guilty is 73. And then if I add up all of these together, that's going to be my 1026. So all probabilities are calculated as, well, unless you're using a formula to find them, you take the number of favorable outcomes and the number of possible outcomes and you divide them. So I'm going to separate these out just so you can see them, but you can also just type it in a formula if you want. Um, so let's see. So the probability of randomly choosing someone and then pleading guilty. Well, there's 1,026 possible people that you could choose a random person from. So that's the number of possible outcomes. And the number of people who pled guilty is 953. So to find the probability, which maybe I'll make a new column for this, I would just take this 953 divided by this. And you don't have to write out these two columns if you don't want to. You could just select these two cells and that's fine. But that's the probability that you randomly choose someone who pled guilty. Now we want to find the probability that you randomly select someone who was sent to prison. So as of right now, we're looking at these as individual events. We're not looking at the probability of getting one or the other. We're just looking at their individual events because the OR formula requires us to know those individual probabilities. So if I'm looking at the probability of choosing someone who is sent to prison, again, I have 1,026 possible outcomes. And the number of outcome or the number of people out of that 1,026 that got sent to prison is 455. And if I calculate out that probability by taking the favorable outcomes divided by the possible, that gives me that probability. Now, the next thing I need to do is I need to find the probability that they pled guilty and were sent to prison. So this is a case where I'm going to find the probability with a formula. So maybe I'll separate those so it doesn't look like it's part of the columns. So in order to do this, I need to know the probability of A, which is pleading guilty, which I've already found. So I've got this part of my formula already taken care of. Now I need to find the probability of B, in this case, getting sent to prison, assuming that A happened or given that A happened. So I'm looking for the probability of being sent to prison, because that's the second event that's I'm looking at, given pled guilty. So what this given thing means is assuming that the first thing happened. So in this case, assuming that they pled guilty, what's the probability they got sent to prison? So because these are dependent events, and most tables will be dependent, I'm going to say the possible outcomes, assuming that they pled guilty, is 953 because there were 953 people who pled guilty. And then the number that were sent to prison, assuming that they pled guilty, is 395. And notice how these numbers are different than just the probability of being sent to prison, because the probability of being sent to prison is out of the total, and the probability of being sent to prison, given that you pled guilty, is only looking at the people who pled guilty. So I'll go ahead and calculate out that. And again, this given idea, if they are independent events and you know that they're independent, like a coin flip or a dice roll or something like that, you can just calculate them as the probability of the second event. But in this case, they are not independent. So this probability will be needed to be able to find the probability of A and then B. So the probability that they pled guilty and got sent to prison, according to this formula here, is the probability that the first event happened, so the probability of event A happening, multiplied by the probability of the second event happening, assuming the first event happened. So that would be that. So that's the probability that you randomly select someone who pled guilty and went to prison. Now, that's not what we were asked for, though, because we were asked to find the probability that they pled guilty or got sent to prison. And this is going to be a higher probability because there were more people who pled guilty or got sent to prison, because some of them might have only pled guilty, some of them might have only got sent to prison, and some of them might have had both. And this is actually the reason why we add them together. So to do this, I'm going to do the probability of the first one, which is the probability of pleading guilty, plus the probability of the second thing happening minus the probability of or of the and probability, which is this one right here. And so that's the probability that you choose someone who pled guilty or got sent to prison. We'll go back here just to double check. So it says round to the nearest thousandth, which is the third decimal place. So I'll type that in. We can see that we got that correct. Now, on this assignment, you will have some questions where you're just asked for an and probability. So, like this one, for example, you're asked to find the probability that they entered a guilty plea and were sent to prison. On question 8, this one says if two different defendants are randomly selected, what's the probability that they both enter guilty pleas? So in this case, if we were trying to find the probability of both, one way you could think about this is that the first is guilty and the second is guilty. So the way that you would calculate this one is you would first find what's the probability that the first pleads guilty. And maybe I won't copy down the whole table here. I'll just type out my calculations here. Actually, I do need to know the totals, so that would be easier. Just a minute. I don't know why it's not downloading, but oh, there it is. Okay, so I copied and pasted this, got it all tidied up. So if I want to find the probability of the first being guilty and the second being guilty, which is another way of saying that they both entered guilty pleas, the probability that the first person is guilty is going to be out of the total. So I'll need the sum of all of these. And I will also need the total number of people that are guilty. So I'm going to add up this column of people who are guilty. So I will calculate this as the number of guilty or people who pled guilty divided by the total number of people. And that's the probability that the first person is guilty. And notice here, I didn't make a bunch of columns. So this is an example of what I was talking about on the last example where you don't have to type out all the columns. But sometimes it can be helpful to think about like what's the number of possible outcomes? What's the number of favorable outcomes as like separate steps before you do your calculation. So kind of up to you on that. But we find the probability of the first thing happening, and then we need to find the probability of the second thing happening given that the first thing happened. So in this case, that the first person pleaded guilty. Now, this one's kind of interesting because we are choosing two different defendants. So if we assume that we randomly select someone who was guilty, then the second person is going to be, or the probability for the second person is going to be 942 divided by 1017. And those numbers are one less than these two numbers because if you have 1,018 people and you select one person and there's someone who pled guilty, that means you only have 1,017 people left to choose the second person from. And 942 of those people pled guilty. And so that's how you would calculate the probability that the second person was guilty, given that the first was guilty. And once you have those two parts, so basically I have these two parts of the formula, then I can find the probability of the first person being guilty and the second person being guilty by multiplying those two probabilities together. And that gives me 0.858 and so on. So that's how you would do a problem like that. Now, I think it was question 6, I want to say. Yes. So on this one, you're given a bunch of different musical selections. So you have 60 musical selections, 35 are rock, 20 are jazz, 5 are blues, and the player is set on random play, so the selections are played randomly and they can be repeated. And if you're asked to find the probability that the first 4 selections are all jazz, the way that you would calculate this is by taking 20 out of 60, because that's the probability that the first one is jazz. And then you want the second one to also be jazz, and the third and the fourth one. And so this is basically the and formula repeated multiple times because you want to get jazz and jazz and jazz and jazz. And so when you multiply your probabilities, instead of just multiplying 2 probabilities, you're going to multiply 4 probabilities together. And since the selections can be played randomly and can be repeated, the probability of each event is just going to be 20 out of 60. If they said that they could not be repeated, then you would do like 20 out of 60 for the first one, but then the second one would be 19 out of 59. And the third one would be 18 out of 58. Because if you can't repeat a jazz song, if the first one is jazz, there's less songs for the second one to be jazz. Um, and so on. So anytime you have like multiple events and they want them to all be jazz or to have whatever outcome it is, but you have like more than just 2 events, excuse me, you basically just extend this and formula that we were using, but you'll multiply like multiple probabilities together instead of just 2. So that's how you can do the and or formulas in Excel. I hope this was helpful, and if you have any questions, please let me know.